Okay, so we're on recording now, and I'm going to make you the host. Thanks for reminding me.
Alrighty, no problem.
Okay. Okay. Okay, so there are two problems on the board. I'm going to give you a couple of minutes to try these as a reminder of what we were doing in chapter 6, the chapter we're working on now.
Right. Professor, I think you're gonna have to pin yourself.
I'm going to have to what?
Pin yourself.
I am pinned. No, you have to.
Oh, okay. Okay.
That's how it works. You have every individual has to pin me. Otherwise, it just goes to the and Melissa, mute everybody, and then I'll unmute myself.
You want everybody to be unmuted, you said?
No, mute everybody, but then except I'm gonna have to unmute, then I'll be muted also. I'll unmute myself. That way, I will come up as the one who's then it won't be a problem with the pinning.
Good morning.
Good morning. Okay, I think we should get started now. I'm going to do the first question as a and then we'll go over the second one so that we can continue with our discussion of radicals, square roots especially. And if you recall the rule about combining radicals, you can only combine like radicals, just like you can only combine like terms, you can only combine like radicals, which means that whatever inside the radical sign has to be the same for each term. But what we can try and do is simplify. Sometimes by simplifying, we'll find that we actually do have like radicals when it looks like originally we don't. And I do that by taking each radical and breaking it up. Like, for example, this 12, I'm going to break it up into two numbers. One number is going to be the perfect square, and the other number is whatever it's left over. And I know that 12 multiplies to 4 and 3. So I'm going to change the square root of 4 to 2. And remember, I have this negative 2 in the front as a coefficient, but now I can multiply this negative 2 times the 2 because these are both outside the radicals. So that will give me negative 4 radical 3 for my first term. Then I go to the next thing, which is the 300, the square root of 300. And I think, oh, what can 300 be broken up into? And I think, oh, 100 and 3, because 100 is a perfect square. And the square root of 100, of course, is 10. There's nothing in front of it except a minus, so this becomes minus 10 radical 3. Remember, the number that's the perfect square, you take its square root, and then you no longer have the radical on top of it. Finally, I have the square root of 18. So the square root of 18, I think, when I think about breaking it up, I break it up into 9 and 2, because the square root of 9 is a perfect square. Remembering that there's this 3 in front of it to start out with. And again, the square root of 9 is 3. But now I have the 3 in front of it times this 3, which is now no longer inside the radical. That gives me plus 9 radical 2. So step 1, I simplified everything as much as I possibly can. Now I look for like radicals. And the negative 4 radical 3 and the negative 10 radical 3 are certainly like radicals because they both have 3 inside the radical. So I combine the negative 4 and the negative 10, which gives me negative 14 radical 3. But I can't add the 9 radical 2 because these are not like radicals. So my answer in simplest form came out to be negative 14 radical 3 plus 9 radical 2. Does anybody have any questions about that? Okay.
Could you go, Professor, sorry, could you go over it one more time, please?
Or do you want me to go over the whole thing or just the end?
The whole
Just
thing would be
so-
good for me.
Okay, fine. Okay, good.
Okay, so I'm going to erase it and go do it all over again, okay? I'm starting as if I never did it before. Let me see if I can maybe give myself more space. What happens is these things sort of get messy because there's so many things going on. Okay, so I'm starting out with the radical 12. I want to break up 12 into two numbers that one of them is a perfect square. And I think, oh, 12, I can break it up into 4 and 3. So I will write this as the square root of 4 times the square root of 3. Now, the 4 is a perfect square. When I take the square root of 4, it just gives me 2. No longer inside the square root. The 3 I can't do anything with because 3 is not a perfect square. I just have to leave the 3 inside the radical. But I also had this -2 in front of this. Now, the rule is that when you have numbers that are outside the radicals, they can be multiplied together. Numbers that are inside the radicals can be multiplied together. What you can't do is take a number that's outside the radical, like this -2, and multiply it with a number inside the radical, which is the 12. So now if I see this -2 can be multiplied by this 2 on the outside because they're both outside the radical. -2 times 2 gives me -4, and I just bring down the radical 3. That takes care of the first term. Is that okay? Can I go to the next one?
Yes,
Yeah.
yes, please. Thank.
So I look at the next thing I have is a 300. Again, I'm thinking of numbers that multiply to 300, and one of them has to be a perfect square. Now, sometimes there's more than one choice, but you always want to pick as big a perfect square as you can. And it hit me that 300 could be broken up into 100 and 3, because 100 is a perfect square. So I take the square root of the 100 because it's a perfect square, so that just becomes plain 10. Outside the radical, there's a negative in front of it, so that becomes -10 radical 3. And finally, I go to this last term, which has a radical of 18. And I think, okay, what can I break 18 into? And I thought of 9 and 2. So I'm going to break this up into the square root of 9 and the square root of 2. And the square root of 9 is just plain 3. But remember, there was a 3 in front of it from before. So now this 3 from outside times this 3 up from that's now come out of the radical becomes 9 radical 2. Are we so far okay?
Yeah.
Okay.
Yes.
Okay. So now I just look at it. Now I start looking at the problem again. Now that everything is simplified, I look, are there any like terms? Are there any like radicals? And the first two are. So when I'm combining them, I just work with the numbers in front. -4 and -10 together gives me -14. So that's -14 radical 3. But I can't add the 9 radical 2 because it's like this is the x's and this is a y. They're not like terms. So this is my final answer after everything is simplified. Did that make it clear?
That was good.
Yes, Professor. Thanks much. Yeah.
Okay, so now let's look at this next one. This next one is, I have a 3 radical 5 on the outside of the parentheses times 2 radical 20 minus 4 radical 5. Now, I could, if I want, try to simplify these radicals. I could. But since there's a multiplication involved, and usually at the end of the multiplication, I have to again simplify the radicals, I usually just do the multiplication first and then work on the simplification. Now this is a single term times a binomial. So I'm going to have to use a distributive property. In other words, I'm going to have to multiply the 3 radical 5 times the 2 radical 20. And also the 3 radical 5 times the 4 radical 5. Okay, so I'm going to distribute this 3 radical 5 times each of these. So remember what I said the rule is. any numbers, when you're multiplying, any numbers that are outside get multiplied together. So this is 3 times 2, which is 6. And any numbers inside the radical are multiplied together. So that gives me 100. Going to the next term, of course, I'm going to have to simplify this, but let's do the multiplication. I'm going to do the same thing. I have a negative 3 times a 4, because those are both outside. That gives me negative 12. And then I have radical 5 times radical 5. Now, if you recall what I said about multiplying a radical by itself, is it really is a shortcut. Obviously, I should say it's square root of 25, and the square root of 25 is 5. But the shortcut is that whenever you're multiplying a radical by itself, you're really just getting the number that's inside the radical. In other words, if you have the square root of x times the square root of x, obviously that will give you the square root of x squared. And we know when we're taking the square root of x squared, we divide the exponent by the index, and it just gives me x. So when I have the square root of 5 times the square root of 5, it's just going to give me plain 5 without any radical. I could do it the long way, but I'm always looking for shortcuts because it saves time. So now I'm going to finish this up. This square root of 100 becomes just plain 10. And now the 10 is no longer in a radical, so it becomes 6 times 10, which is 60. And this is 12 times 5. And remember, the 5 is outside the radical. The square root of 5, the square root of 5 became a 5, not in a radical. So that's also 60. And I have 60 minus 60, so my final answer for this was 0. Now, if you wanted to, you could have put it into your calculator, as long as you put it in exactly the way it says here. 3 radical 5, parentheses 2 radical 20, minus 4 radical 5, close parentheses. If you put it in your calculator, you would get the exact answer 0. That's what you did, Emma? You put it in your calculator?
Yeah.
And there's nothing wrong with doing that. But of course, I'm not going to do it on the calculator. I'm going to do it the right way. It isn't even the right way or wrong way. I'm going to do it the long way. But if you know how to use your calculator properly, and that's why it's so important to practice with your calculator, you're going to get a lot of these answers without spending a lot of time working them out. Again, I will constantly work them out, but this is the long method. You really can use your calculator. Again,
Professor,
it takes a little bit of practice. Yes.
okay, so the number in the radical is 5. It stays the same?
Yeah. Okay. When you have a number in the radical multiplied by itself, it's the same thing. You can't have just a square root of 5, but if you have the square root of 5 times the square root of 5, what that's doing is it's removing the radical and just becoming 5 without a radical. Does that answer your question, Shira? I think it was good, Shira, right?
Yes. Yeah.
Yeah, is that okay?
Yes.
Okay. Are we ready to go on from here? Okay. So let's continue with where we had left off. Can I erase this now? Anybody still want it on the board? Okay. My next question is, and this is, we had done one of those questions last time. And by the way, I am going to spend some time at the end of the period, just reviewing some of the questions that are on the Delta Math quiz. If anybody has questions that they want to ask me about the Delta Math quiz, you can ask me at the, let's say, I'll stop at 10 after 11 and do some review. Okay, so we were in the middle of multiplying radicals, and we talked about what happens when we're multiplying radicals that are binomials. For example, if I gave you something that looks like this, 3 minus 5 radical 2 times 4 plus 2 radical 2. These are binomials. They can't be simplified any further. Don't think you could combine the 3 and the negative 5 because the 3 doesn't have a radical 2 next to it. This was similar like having a 3 minus 5x. They're not like terms. They can't be combined any further. So there are 2 terms here and there are 2 terms here, and I want to multiply them. And I know how to multiply binomials. The method that we use is something called FOIL. And it's going to work with these binomials with radicals just like it works with binomials with letters, with variables. At first, multiply the 2 first numbers together, which is the 3 and the 4. That gives me 12. Then my outer, I multiply the 3 times the 2 radical 2. Now this 3 is outside the radical, so I have to multiply it by this 2 that's outside the radical, which gives me a 6. There's no radical to multiply this 2 by, so I just bring down the radical 2. Then I go to the inner. The inner is the negative 5 radical 2 times the 4. Again, I'm going to multiply the negative 5 times the 4, because those are numbers that are not inside radicals. That gives me negative 20. And there's nothing to multiply this radical 2 by, so I just bring down this radical 2. And finally, I do the last, which is the negative 5 radical 2 times the positive 2 radical 2. Well, let's think. Negative 5 times positive 2, those are outside the radicals. That gives me negative 10. Then inside the radical 2, the radicals, I have a radical 2 here times a radical 2 here. That's where I can use my shortcut. A radical times itself is just the number inside the radical without the square root sign anymore, because that's what happens. Really, you could write it as radical 4 and then change it from square root of 4 to 2, but this is the short way. Of course, now these are no longer in radicals, so I can multiply these together so that it becomes negative 20. And now I look for like terms. So first I look for numbers that don't have any radicals attached to them. There's a 12 here and a negative 20 here, which will give me negative 8. And then there's a 6 radical 2 and a negative 20 radical 2. Those are like radicals because they're both attached to radical 2. So I combine the 6 and the negative 20. That gives me negative 14 radical 2. And these can't be combined any further. Sometimes, and there would be nothing wrong with the writing it also as negative 14 radical 2 minus 8. It doesn't matter which term you put first or second, as long as you keep the sign together with the number. Again, don't try to combine these two numbers because this 8 doesn't have any radical 2 next to it.
Professor
Okay.
Tsai, how did you get negative 8 again? I'm sorry.
I had this 12 from before, right?
Mm-hmm.
Doesn't have any radical next to it.
No.
Is there anything else that doesn't have a radical next to it?
Oh, the negative 20. So negative 20 plus 12 will be negative 8.
Negative 20 together give me negative 8. And again, you could have stuck this, if you have one of those calculators that have something that's called Math Print, or I think most of them call it Math Print, something that looks like this, Math Print in you. And again, if you're not sure if you do or not, you can always email me a picture of your calculator. Then you could stick this into your calculator and it will come up with this answer. Emma, did you do that?
No, I'm still trying to do it your way.
Oh, okay. I prefer you do it my way, but it's a good way to, if you have a calculator that does it, you can then use your calculator to check also to see that you've done it correctly. Any questions about this? Are you ready to try one on your own? Okay. So can I erase this? Anybody still need it on the board?
Hold on. Wait a second.
Sure.
Okay, you can erase it now.
Thanks.
Wait, in the bottom you distribute it?
What, this one or this one?
Both.
Okay, no, what I did is after I had done the multiplication, and I did 4 multiplications because first, outer, inner, last, I looked to combine like terms. Remember, this is think of this as an X and this is an X. So this would be a 12, a 6X, a minus 20X, and a minus 20. So the like terms are the 12 and the negative 20 because they aren't attached to any radicals. So 12 and negative 20 combine to negative 8. And the 6 radical 2 and the negative 20 radical 2 are like terms because they're both attached to radical 2. So I add the 6 and the negative 20, which gave me negative 14. So that's where the negative 14 radical 2 is. And I just said, this is really the correct answer, but if you had put it in the other order, that would be correct as well. Does that answer your question?
Yeah.
Okay. Can I now erase this and give you one to try on your own?
Yes.
Okay. Okay, what if I would have given you 3 radical 5 minus 2 with a square on the outside? What would you have had to do with this? What happens when you have a binomial squared?
I mean, you can just write it out.
Right, you're gonna have to write it out as 3 radical 5 minus 2 times 3 radical 5 minus 2. Okay, so if you have a binomial squared, just write it twice and just do the regular FOIL. Okay, I'm going to give you time to do that while I take attendance. Azia?
Yes, Professor.
Good morning. Nashia Allen. Nashia Allen here? Annabelkis Baez. Annabelkis? Emma?
Present.
Good morning. Messiah? Messiah?
Here.
Good morning. Corey? Corey Brown? April? April?
Good morning.
Good morning. Khadija?
I'm here.
Oh, good. I have you absent for the whole last week. Is that correct?
Yeah, because I was sick, Professor. Sorry.
I'm sorry you were sick. I'm glad you're back.
Thank you.
Umar Diallo. Yakima,
Here, Professor.
good morning. And
Good
Gloria
morning.
also. Cheryl. I know you're here.
Good morning,
Good
Professor.
morning. Stacia,
Good morning, Professor.
good morning. Denisha Harris. Denisha here? Devana. Devana, I know you're here. Natalie,
Yes, Professor, I'm present.
Erica,
Good morning, Professor.
good morning. Jonathan, I know you're here. Luke Minot. Luke here. Layla,
Yes, I'm here, Professor.
good morning. Ashley,
Good morning.
good morning. Kachira,
Here.
good morning. Jennifer,
Good morning. I'm here.
good morning. Rachel,
Good morning. I'm here.
good morning. And Gloria. Okay, let's see if we can work on this now. Again, we're going to use our FOIL. We'll multiply the 3 radical 5 times the 3 radical 5. So 3 times 3 give me 9. And radical 5 times radical 5. Oh, that's that special case. It just gives me a plain 5 without a radical. And of course, now I could multiply the 9 times the 5, and that gives me 45. Okay, that takes care of the first term. Now we have outer. The 3 radical 5 times the negative 2. So the 3 times the negative 2 gives me negative 6. And there's no radical next to the 2, so I just bring down that radical 5. Then I do inner, which is the negative 2 times the 3 radical 5, which again gives me negative 6 radical 5. And finally, I do last, negative 2 times negative 2, which is positive 4. And now I look for my like terms. Here's a 45 and the 4. Those are like terms because they don't have any radicals next to them. 45 and 4 is 49. And the negative 6 radical 5 and the negative 6 radical 5 are also like terms. I add the negative 6 and the negative 6, which gives me negative 12 radical 5. And here's my answer, 49 minus 12 radical 5. Any questions as to how to get that answer? Were you able to get this?
Mm-hmm.
Okay, great. All right, I'm going to give you a similar but somewhat different problem. Okay? Can I erase this?
I'm good.
Okay,
Everyone else good?
Mm-hmm.
okay.
Go ahead.
Here's the problem I'm going to give you. I want you to multiply 3 radical 5 minus 2 times 3 radical 5 plus 2. Now, this is not the same thing as what we did before, because before when we did the binomial squared, I had to multiply them both with negatives. But now I'm multiplying, they look almost identical, these two binomials, except one has a plus and one has a minus. If you remember, we did give a special name to this. We called these conjugate binomials. Let me see if you could multiply these conjugate binomials and see what kind of answer you come up with. I'm going to give you a couple minutes. Okay, let's see if we can do this together. I'm going to use FOIL for this. And after I do FOIL with this, I'm going to show you actually a quicker way of doing this because these are conjugates. Okay, but using FOIL, we again will multiply the 3 radical 5 times the 3 radical 5. And like before, we'll get 3 times 3, which is 9. And radical 5 times radical 5, which will give me 5. Not in the radical anymore because I multiplied it by itself, which will again give me 45. So that's exactly what we did before. Now we do the outer, 3 radical 5 times plus 2. So the 3 times the 2 gives me plus 6 radical 5. The inner, when I multiply them, is negative 2 times 3 radical 5. So the 2 and the 3 gives me negative 6 radical 5. And finally, the final terms are -2 times +2, which is -4. And now we want to combine the like terms. And what I notice is the inner and the outer, the two middle terms, are exactly the same, except one is positive and one is negative. So when I add the 6 and the -6, I get 0. And 0 times radical 5 is just 0. And so that just cancels out. And then I have this -4. So I combine the 45 and the 4, -4, and my final answer comes out to be 41. If you notice, I started out with two rather complicated binomials. They both had radicals in them, but what happened is that after I multiplied, I was left with a single, what we call rational number, a number that doesn't have any radicals at all. It is just the real number 41, the rational real number.
Professor,
Yes,
that's the same one from before?
it's not exactly, because this one from before had both minuses because it was the binomial squared. And this one has a minus and one has a plus. So slight difference in the problems. The two parentheses are not identical. They're very close, but one is a minus, one is a plus.
How do we all right, how do we difference it? Like, how do we know when to put both of them -2 or when to put one of them -2 and the other one +2?
No, I'm sorry. It's not this problem. If they give you the thing with a binomial with a square on the outside, you have to write it the same thing both times. Only when you were given these two separately, you can't use it as a square. Is that clear? I'm sorry, I didn't erase the whole problem before.
Yeah, that's why, because I was confused.
This is an entirely different problem.
Professor,
Yes.
okay, so I understand what you're doing, and I am doing my best to grasp it. I just think if I do it a few more times, I'll get it.
Okay.
But once I put it into my calculator, I don't know what the hell's wrong with it. It just gave me the same. It gave me 3 radical 5 minus 2 squared. It didn't answer the problem.
And you put equals?
Yeah. I'm gonna have to send you a picture of my calculator because I'm really getting annoyed.
Okay. I feel bad because you probably have a very good calculator.
It is.
Here's what I want you to do. This Jennifer, is that who I'm talking to?
Yeah, it's me.
Okay, Jennifer, here's what I want you to do. Send me a picture of your calculator. And then on Thursday, can you get on early?
Yeah, I'll get on early on Thursday.
And then I'll talk to you individually about your calculator.
Okay, no problem. Thank you so much.
Send me a picture first so I know exactly which calculator I'm talking about.
Okay, I appreciate it.
Okay. No, because it's a shame if you have, and this is for anybody, make an appointment with me to talk about how to use your calculator if you're not getting the most out of your calculator. Some of these calculators would do all these problems for you with just, if you put them in the correct way. Okay, let me just continue what I was saying. When I am multiplying conjugate binomials, and I will recognize that I'm multiplying conjugate binomials because I'll have two separate parentheses where the two binomials will look almost identical, but in one case I'll have a minus, and in one case I'll have a plus. That'll tell me that I'm multiplying the conjugate binomials. Then I know it's going to happen that the inner and the outer terms are going to cancel out. Because they will turn out to be always the same numbers, but one will be plus and one will be minus. And we noticed that because when we did it with regular variables, we always turned out if we had a plus b times a minus b, we got a squared minus b squared. We didn't end up with 3 terms, we only ended up with 2 terms because the middle terms cancel out. So if I know that's going to happen, here's what I'm going to do. I'm going to redo this problem. I'm going to show you the short way to do this problem. I look at the problem. It hits me they are conjugate binomials. I know the middle terms are going to cancel out. So just do first and last. Because inner and outer for sure are going to cancel out. So I do the 3 radical 5 times the root of 3 radical 5, which gives me 9 times 5, or 45. And then do the last, negative 2 times positive 2, which is minus 4. And do 45 minus 4, and your answer is 41. It turns out whenever you multiply conjugate binomials with radicals, your final answer will be a single number without any radicals. And you get it by just multiplying the 2 first terms together and the 2 last terms together. You don't have to bother with outer and inner because you know they're going to cancel out. Okay? Let's see if you can do this one the quick way. What if I gave you this? Giving you a minute to try this. And really, I'm only giving you a minute because these are the quick ones. Okay, let's do it. I see they are conjugate binomials because the 2 look identical, except one of the signs in the middle is negative and one of them is positive. So I know I can get away with just doing first and last. First, 3 times 3 is 9. Last, negative 5 times positive 5 is negative 25. Radical 6 times radical 6 is that special case where all we're getting is the 6 not in its radical. Now I multiply the 25 and the 6, which is 150. So this becomes 9 minus 150. Remember, of course, you have to do the multiplication before you combine it with the 9, which is negative 141. Any questions about that? Okay, so we want to keep our eyes open because sometimes when we see something like this, instead of going through the whole FOIL, we can avoid a lot of work just by doing it first and last because they are conjugate binomials. Okay, so I think we've pretty much taken care of adding, subtracting, and multiplying. So of course, now we want to talk about how do we deal with division with radicals? What do we do when we have fractions with radicals? How do we take care of dividing radicals? And I'm going to do it in 2 steps. I'm going to do it in 2 steps where the first step will be when my denominator, what I'm dividing by, is a single term. And then I'm going to talk about what happens when we try to divide by a binomial, because that's a different set of steps. Okay, so let's take an example like this. And I'm going to give you, I'm going to give you a way of always approaching it. Now, some people might do it a slightly different way. If you know how to do these problems and you have a different method, you can continue to use your method. But my method will always sort of be, I'll always approach the problem the same way. So I won't say, oh, this problem I'll do this way and that problem I'll do another way. Okay? So the first thing I'm going to do is, what happens if I have a fraction that looks like this? The square root of 25 over 36. In other words, I'm dealing with fractions and division at the same time. Now, what I always like to do is that whenever I have a fraction inside a radical, I want to split it up. It really means the same thing as having the square root of the numerator, in other words, the square root of 25, over the square root of the denominator. In other words, if you have a fraction inside a radical, break it up into a radical in the numerator and a radical in the denominator, and simplify your numerator separately and your denominators separately. Okay, this one happens to be relatively easy because both this 25 and the 36 are perfect squares. So the square root of 25 is 5, and the square root of 36 is 6, and my answer came out to be 5 over 6. So that's step number 1. Look at your fraction. If it's a whole fraction in a radical, just make it a numerator separately inside a radical and a denominator, so that you're only, whenever you're dealing with it, you're only dealing with square roots of numbers, not of fractions. Okay, let's try another one. What if I had the square root of 10? Okay, let's do it. Suppose I have the square root of 12 over the square root of 50. How do we deal with something like this? Notice neither the 12 and the 50 are perfect squares. Well, I'm going to do exactly what I did before. I'm going to, again, there are other ways of doing this, but this is the way I like to approach it, because then I'm consistent and always doing the same thing. Whenever I see a fraction inside a radical, I'm going to put the square root of the numerator over the square root of the denominator. In other words, I'm going to separate it into radical 12 over radical 50. Now, 12 is not a perfect square, but I can simplify radical 12. Remember, we learned how to simplify. This we can break up into 4 and 3. So this becomes the square root of 4, which is 2 radical 3. So far, okay? Okay, let's see what happens on the bottom. I want to simplify the square root of 50. Again, it's not a perfect square, but I can break it up into 25 times 2. And the square root of 25 is 5, and the square root of 2 is what's left over. So, again, step 1, if it's a fraction inside a radical, separate it into 2 radicals and simplify each of those radicals the way we know how to do it. Okay, and I'm going to erase this thing so I can have a little more space. So it looks like my final answer should be 2 radical 3 over 5 radical 2. Except when the term simplified is used with radicals, this is a technical thing, it always means do not leave a radical in the denominator. Make sure you do something that's called rationalize the denominator. So the question is, how do we rationalize denominator? How do we make this denominator into a number without any radical? And it's really not a hard process, because I know, remember with fractions, as long as I multiply the top and the bottom of the fraction by the exact same thing, I will not change the value of the fraction. So after I've simplified my radical in the denominator, I take the number that's inside the radical, square root of 2. Now, I know whenever I multiply a radical by itself, it just gives me the number that's inside the radical multiplied by the square root of 2, because I know the square root of 2 times the square root of 2 will just give me plain 2. But since I'm multiplying the bottom, and again, I knew to use the square root of 2 because that was the radical in the denominator. But whatever I do to the denominator, I have to do the exact same thing to the numerator. So I'm going to have to multiply the numerator by radical 2 as well. Remember, when you have a radical 2 over radical 2, you're really just multiplying by 1, which means you're not changing the value of the fraction. So it turns out that in the numerator, I have 2 radical 6, because the 3 and the 2, they're both inside radicals, so they can be multiplied. On the denominator, I have 5 times 2. Remember, the radical 2 times the radical 2 just gave me 2, so that gives me 10. And then I ask myself, can I reduce this fraction? And just like when you're multiplying, if you numbers outside radicals, you can multiply them together. And numbers inside radicals can be multiplied together. With division, the same thing is true with fractions. This 2 and this 10 are both outside radicals. They're not inside the radicals. So I can reduce this by dividing the top by 2 and the bottom by 2. So that my final answer turns out to be radical 6, because this is just a 1 now, over 5. So we took this radical 12 over 5 and ended up with radical 6 over 5. That is the simplest form of this example. Does anybody have a question about that? Devon, you were close. It isn't plain 6, it's square root of 6.
I have a question.
Professor, I just don't know how to write the radical from my computer.
Oh,
Maybe I should spell it out. I'm sorry, did I interrupt somebody?
it's okay. Jonathan was going to ask a question, but
Sorry,
you could
Jonathan.
just say
Oh,
square
it's
root
fine.
or do SQR or something like that. I know that I don't know how to do it on the chat personally. Okay, Jonathan, you had a question.
Yeah, so when you said about rationalizing the denominator, for example, if the denominator, for example, in a random problem, if we had a denominator saying, like 6 and over radical 5, we would do the same process in terms of
Right.
multiplying the rational 5.
Anytime you see a radical in the denominator, you're going to have to rationalize it. If any term like simplify is used, it means you must not leave a radical in the denominator.
Okay.
And it doesn't matter. Let's do another problem. I could give you something like this. 2 over radical 7. Now, it looks very simple. But if the term is used simplify, you have to do something with it because you have a radical in the denominator. Now, what should I do with this?
You can just multiply it by the
Right.
denominator, basically, on the both numerator and denominator.
Right. I look at my denominator. I can't simplify it any further. The 7 is I can't get it down to less, but it's still a radical. So I multiply by radical 7. Remember, my decision is always based on what's happening in the denominator. But whatever I do in the denominator, I have to do the same exact thing in the numerator. So what am I left with? I'm left with 2 times radical 7, because the 2 is outside the radical and the 7 is inside. I can't multiply those. And on the denominator, I'm left with radical 7 times radical 7. And I know when I multiply a radical by itself, it just gives me the number 7. And don't think you could take this 7 that's inside the radical and this 7 outside a radical and cancel them. You can only work outsides with outsides, inside with inside. So this would be your final answer. And somebody's going to tell me, hey, I like this one better. It looks simpler to me. It doesn't matter what you like. This is it's a technical, it's like, it's a definition. This is what they mean by simplify. Make sure the number that you're left with in the radical in the denominator doesn't have a radical.
Thank you.
Okay, let's try one more. I'll give you one to try. Let's see. What if I gave you suppose I gave you the square root of 3 over 8. See if you could simplify this. I'll give you a couple minutes to try that. Okay, so let's look at this fraction 3 over 8 in the radical. Okay, so I'm going to follow my steps. I'm going to separate it. I'm going to put the 3 in a radical over 8 in the radical. So whenever I don't like to deal with fractions inside radicals, so I just make it 2 separate radicals. And again, the 3 can't be simplified, but the 8 could be broken down into 4 and 2, because 4 is a perfect square. So this becomes 2 radical 2. So step 1 is we get to radical 3 over 2 radical 2. That is our first step. See separate your fraction into and simplify both the top and the bottom. But you can't stop there if there is still a radical in your denominator. Now, I don't care what else is there. What I care about is radical 2. So since I have a radical 2 in the denominator, I'm going to multiply that by radical 2. But of course, then I'm going to have to do the numerator by radical 2 as well. So that'll end up giving me radical 6, because 3 times 2 are both inside the radicals, they get multiplied together. And over here, the 2 is on the outside, that's that 2. And now I have radical 2 times radical 2, which is also a 2. Remember, that was the whole point. When you multiply a radical by itself, it gets rid of the radical. So I have this 2 originally from here and this 2, so that it ends up with radical 6 over 4. Now, notice I can't go any further, even though these look like they should be able to be reduced, because the 6 is inside a radical and the 4 is out. So that's my answer in simplest form, radical 6 over 4. Is it simpler? It doesn't matter if you think it's simpler, it's what they want. It's what is required when the term simplification is given. All right, now I said we've just been dealing with fractions that have a single term in the denominator. Now let's see what happens when we have a binomial in the denominator. Let's say I had something that looks like this. Can I erase this? Suppose I have 4 over 2 minus radical 3. And if you notice in my denominator, I have a binomial, and my binomial has a radical. And I somehow want to get rid of this radical. And now I'm going to make use of something that we just talked about before. I know that when I multiply a binomial by its conjugate binomial, that I end up with just having to multiply the first and the last. And on top of that, I always end up with a single number, a single rational number. So when my denominator is a binomial, don't multiply by the square root of 3, because the square root of 3, you'd have to distribute it, and then you'd have a 2 radical 3. It won't get rid of the radicals. Multiply by the conjugate. Now, what's the conjugate of 2 minus radical 3? That is 2 plus radical 3. Conjugates are identical binomials with the opposite signs. But of course, if I'm multiplying the denominator by 2 plus radical 3, I've got to multiply the numerator by that as well. So when it comes to a fraction or a division, sometimes they use the term divide, sometimes they say simplify the fraction, and the denominator, divisor, is a binomial. It's multiplied by the conjugate of that binomial. Now let's see what happens. So in the numerator, I'm just going to leave it 4 times parentheses 2 plus radical 3. I'm really going to concentrate. I'm not even doing the multiplication yet. I'm concentrating on what's happening in the denominator. I'll worry about the top in a minute. So what do I know? I know that when I'm multiplying conjugates, I don't have to do the whole process of FOIL. I can just do the first 2 times 2, which is 4. And the last, negative radical 3 times positive radical 3. Well, the negative times the positive will be negative. And the radical 3 times the radical 3 will simply give me 3. Because when you multiply radical by itself, you end up with a number without any radical. So the denominator comes out to be 4 minus 3, which can be simplified simply to
1.
So that my answer comes out to be 4 parentheses 2 plus radical 3 over 1. Now, if it's over 1, I don't have to put it in put the 1 there. I could leave my answer this way, but usually we actually multiply this out, and this I'd have to use the distributive property. 4 times 2 is 8, and 4 times radical 3 is 4 radical 3. Both of these answers would be considered correct. 4 with the parentheses 2 plus radical 3, or without the parentheses 8 plus 4 radical 3. Don't forget to use the distributive property. Remember, there's an understood 1 in front of here. Notice the denominator is understood to be 1, so the denominator has been rationalized. So again, when you have a binomial in your denominator, instead of just multiplying by the radical, multiply by the conjugate of the binomial, and that will get rid of your radical in your denominator. Again, it's the denominator that you concentrate on, because that's where it doesn't matter if you're left with radicals in the numerator. You can have a radical in the denominator. Are you ready to try one on your own?
Yes.
Okay. This is from the practice sheets that I've sent you out. Can I erase this?
Mm-hmm.
Okay. Okay, it's 7 over 9 minus radical 7. Let's see what you can do with that. And mind you, if you have one of your calculator in Math Print, you could put this in, but if you put it in your calculator, you would have to put in as 7 and then your division sign, or unless you have a fraction button on it, and then parentheses 9 minus radical 7. If you're using the division sign, you must put the parentheses to show that you're dividing the whole denominator by you're dividing by the whole denominator. Okay, but we're gonna do it using what I just told you. I see that my denominator is a binomial. So to rationalize it, I'm going to multiply by the conjugate of the binomial, which will be 9 plus radical 7. And of course, that's because this was a minus, I have to do the one with a plus. And of course, whatever I do to the denominator, I do the same thing to the numerator. And I'm going to do the same thing I did before. I'm first going to just write it as 7 parentheses 9 plus radical 7. I'll worry about this at the end because sometimes actually they put the answers with the parentheses and sometimes they don't. So you may as well keep it in the parentheses in the numerator and then check, especially if it's going to be a multiple choice test, check if your answers have parentheses or not. They'll either give it one way or another. And there's no way of knowing ahead of time which way they're going to want to put the answer. But in the denominator, you actually have to do the multiplication. And remember, since these are conjugates, you just do the first times the first. 9 times 9 is 81. And then you do the second, the last. Square root of 7 times 7, square root of 7 plus times minus is minus, and it's just a plain 7, not inside a radical. So that my answer comes out to be 7 parentheses 9 plus radical 7 over, now these are just two regular numbers. 81 minus 7 is
76, 77,
74, no?
74. Oh, excuse me.
And I can't reduce this because 7 and 74 don't go into anything. I could leave my answer like this in the factor, I'll call it the factored form with the parentheses, or if I had wanted to, I can use the distributive property and multiply 7 times 9 is 63. 7 times radical 7 is 7 radical 7. And the whole thing over 74. Remember, the whole thing has to go over. Both of these are considered correct answers. But again, what we have to remember is that when we want to rationalize the denominator, which we do whenever we see a radical in the denominator, if it's 2 terms, I multiply by the conjugate. If it's just 1 term in the denominator, I just multiply by the radical itself. Okay, I'm going to stop here because I want to see if anybody has any questions still about things that are on the chapter, the Delta Math quiz on chapter 5. Is there anybody? Does anybody have any questions about any of the types of problems that they're encountering? Let's see if I can come up with anything. Those of you there, I saw a few of you people did do the examples. Was there? Those of you that already did it, did you find any particular type of problem that you thought was more difficult that we hadn't covered well? Okay, so if not, if there's no questions, then I'm going to then just leave this until Thursday. Remember, you have until the quiz is due on Friday. So you have until Friday. I think I made it Friday evening to do that quiz. If you haven't done it now, make sure to do it before that time. If you have any questions, I'm giving Thursday. I will spend some time on Thursday answering any questions. If you start studying for it and you find that there's something that you wanted me to go over, I will do that with you. Since nobody seems to have any questions at this point, I'd like to go on to another topic in this chapter. We talked about adding, simplifying, adding, subtracting, multiplying, and dividing with radicals. I want to show you what to do when you have an equation that has a radical in it. How do you solve a radical equation? Okay, so I am going to erase this. And again, I don't get behind on those Delta Math assignments. I pretty much assign one each time we have a class. Sometimes I skip, but most of the time it's after each class there is an assignment, and I'd like you to make sure to do them. So what happens, I'm going to start with a very simple radical equation. Suppose my question was x, the square root of x equals 9. Okay, I want to solve this equation. Does anybody have any idea of what the answer should be? Just thinking about it without any having method, but can you think of an answer? I'm taking the square root of x and my answer is
81,
yes. Why do you say it's 81?
because I know the square root of 81 is 9.
Right.
So
Some people might think, oh, it should be 3, but
no, it's kind of like a reverse of what we were doing.
right, it's just the opposite. We have a number. We don't know what the number is. We just know after we take its square root, the answer is 9. And she's absolutely correct. It's the x has to be 81 because I know the square root of 81 is 9. So if I think about it, what method did we actually use? Well, I squared. And that makes sense. I squared both sides. I know when I'm trying to solve an equation, I always do the opposite operation. If I have something added, then to get rid of the addition, I subtract it. If I had something multiplied, I divided by it. So if I have the square root, I want to do the opposite operation and I want to square. So this, I know when I square x, the square root of x times the square root of x will just give me x, and the 9 times 9 will give me 81. Notice when I'm the side that looks more complicated when I square it actually is easier because whenever I square, whenever I multiply something that's inside a radical by itself, it just gives me what's inside the radical without it. So what if I had something like this? The square root of 2x minus 5 equals 7. What if I had this kind of a radical equation? Well, think about it. The whole point is I want to get rid of the radical. So how am I going to get rid of the radical? I'm going to square it. I'm going to multiply it by itself, just like we did over here. Now this side, when I multiply it by itself, when I do the square root of 2x times the square root of 2x minus 5 times the square root of 2x minus 5, what I get is just the 2x minus 5. That's the whole point. Anything that's in a square root, in a radical sign, when you multiply by itself, just gives you what's inside the radical. On the other side, I have 7 times 7. That's not inside a radical, so I actually have to multiply it by itself. So that gives me 49. By squaring both sides, I get rid of the radical and have a regular equation. 2x minus 5 equals 49. And now I solve it. I do plus 5 to both sides, which gives me 2x equals 54. And when I divide by 2 to get the x, I get that x equals 54 divided by 2, which is 27. And I can check my answer. 2 times 27 is 54. 54 minus 5 is 49, and the square root of 49 is 7. So my answer turns out to be 27. And the whole point is to get that radical all.
Professor,
Yes,
what is this called? This new chapter, this new operation?
this is called radical equations.
Oh, we're solving for x in a radical equation?
Right, we're solving for x. In general, whenever the word equation comes up, it means you're solving. You're finding what the
Copy.
answer, or whatever the letter is. Sometimes they use a different letter.
Cool.
Okay? I want to give you one that's a little harder.
Wait,
What?
let me copy this first.
Oh, okay, sure. Okay, can I erase it now? Are you still copying?
Go ahead.
Okay, thanks. What if I have a radical and then I have something outside the radical equaling something like this? The square root of x minus 5 plus 9 equals 12. What must my first step be, would you think? What would you do first here?
Simplify the radical
Yeah.
expression.
Okay, before I try to get rid of the radical, I want to get the radical all by itself. I want to do what we call isolate the radical. There's this 9 that's outside here. Get rid of it. How can we get rid of it? Subtract 9 from both sides, so that you end up with the radical x minus 5 equals 3. So your first step in a radical equation is to make sure that on the one side with the radical, that's all you have. You don't have anything that's outside that radical. Did we ever have a situation like this before, that we isolated something? Do you remember when we did absolute value equations? Those things with those 2 lines on the side?
Yes.
Always made sure to have that all by itself before we proceeded. So the same thing happens when you have a radical. Before you do anything, make sure you have your radical by itself. Then you can multiply both sides by itself. Notice this side, the square root of x minus 5, when I multiply it by itself, just gives me the x minus 5. Anytime you multiply a radical by itself, it gets rid of the radical. But the other side is 3. When you multiply 3 by itself, that gives you 9. And now you have your simple equation, x minus 5 equals 9. Of course, that you just bring the 5 to the other side. And that gives you x equals 14. Okay, so this includes one extra step. I want to do one other problem with you and then see if you, then we'll leave it there. This is where we'll start off next time with radical equations. Okay, we'll finish up that topic next time, but let's do just one more example. I'm going to erase this and do one more example.
Mommy, come quickly.
What if I had something like this? The square root of 2x plus 1 plus 7 equals 5. Okay, I'm going to give you a minute to try that on your own, and then we'll do it together.
Is there always a solution?
Yeah, I want you to find the solution. Are we up to doing it together? Or anybody want more time? Okay, doesn't seem, you want, okay, Cheryl wants some more time, good. Okay, let's do this together because I see we're running out of time. Of course, my first step is to isolate the radical. Get the square root by itself. So I'm going to bring this 7 to the other side. So that'll give me that the radical 2x plus 1 equals -2. What should my next step be? After I have the radical by itself.
I don't know. I still need help with this.
Okay, what would you think your next step should be?
To calculate the difference.
I'm sorry.
Like to multiply and stuff.
Let's multiply both sides by themselves, right? We want to get rid of that radical, don't we?
Yes.
So how are we going to get rid of it? By squaring it. Okay, so we're going to square this side, and it's going to give me just the 2x plus 1, correct?
Yes.
And when I square this side, what am I going to get? Well, -2 times -2 will give me 4.
-4. Sorry.
Give me -4 positive.
Sorry, +4. I always do that. I'm sorry.
Okay, so now I have to bring the 1 to the other side. This will give me 2x equals 3. And then I'll divide by 2. And 3 divided by 2, I can either leave it as a fraction, 3/2, Or if you wanted to, you could write it as 1.5 because 3 divided by 2 is 1.5. Again, which way they give the answer depends on the multiple choice. Sometimes they'll give it one way, sometimes they'll give it the other way. Both are correct answers. Let's check. I just want to show you something, what happens when I check. So if I want to check, I have to check in my very beginning equation. I'm going to replace the x by 1.5. So this is going to give me 2 times 1.5, 2x, plus 1, that's inside the radical, plus 7 equals 5. Okay, let's go a little further. 2 times 1.5 is 3. So this is the square root of 3 plus 1 plus 7 equals 5. And I know the square, 3 plus 1 is 4. And the square root of 4 is 2. So this radical turns out to be the square root of 4, which is just 2. I add the 2 to the 7, and it gives me 5. Well, I know when I do 2 plus 7, I get 9. Does 9 equal 5? What happened here? Something went wrong. I did all the right steps and got the wrong answer because my answer didn't check. So let's see if we can discover where the mistake appeared. Let's go back. I'm going to go all the way back here. I knew that when I have a radical equation, the first step has to be to isolate the radical. So then I ended up with the square root of 2x plus 1 equaling -2. If you recall what I said at the beginning of this chapter, whenever you take the square root of a number, the answer is always positive. You always have to take what we call is the principal square root. In other words, the square root of 49, that's never 7, that's 7. The square root of 4, that's always 2. The square root of a number, just like an absolute value of a number, is always positive. So if I ever end up with a situation where I have a radical equaling a negative number, I know that's impossible. I don't go any further. There's no solution here. I found out when I tried to check the answer that it was wrong, but I could have made this decision right here as soon as I saw that the square root is equal to a negative number. I can stop right there. That's an impossible situation, which means there can be no solution. Okay, so this is where I'm going to stop right now. Melissa, are you doing any?
No, not today.
You're okay. So I'm just going to say, I'm going to leave now. I'm going to leave you.
Sorry. So when the answer is negative, once you do all that up on top, when you get to that point and if it equals a negative, it's impossible. It does no solution.
So you don't have to do any more work.
Okay, as long as it's a negative.
Right. If it's a positive, then you keep going. But if this number is negative, that's not possible. It doesn't make sense. A square root always has to be a positive number, so therefore you can stop right there because it's making a statement that's not possible. Okay, we're going to stop right here. Let me just make one comment about this. On your final, if you have one of these type of questions, you're going to have, it's going to be multiple choice. You could just check the answers because if the answer doesn't check, you're going to have to check your answer anyhow. So you could just take the answer and check it and see if any of them actually work. If none of them work, then there's no solution.
Professor, sir, would it be the answer radical 2x plus 1 equals -2, or is it be 0 with the line?
It's not a zero, it's a zero with a line through it, which means no solution.
So which would be the answer in the final? Do they give it to you as that, or do they give it to you as the first one?
Okay, so there are different ways they might give it to you. They might just write no solution. They might use this symbol, which is a zero with a line through it, which means no solution. Or sometimes they might even give you just a pair of brackets with nothing in it to show you there's no solution. So it could be any one of these ways to show that there isn't an answer to that. But any number, if they gave you a 3 or a 5 or a 7, you know that couldn't be the answer because there is no solution. And answer your question?
Yes, thank you.
Okay. All right. Have a good day. I'll see you on Thursday, everybody.
Okay.
Have a good
Thanks,
day.
Professor. Bye.
If you have any questions that you'd like to bring up about things that are that are on that quiz, certainly bring them up on Thursday.
Mhm.
Bye-bye.